Lesson 29, ticket timers. We will be able to describe how ticket timers work. So we're going to get back to that in a second. What did we do last lesson? Last lesson we talked about average speed. As we just said, average speed is the total distance divided by the total time taken. You could even just rip this straight from this slide. We did some examples where we went, okay, cool. It's this far to get from Melbourne to Geelong. We divide that by time. But remember that that's not necessarily this, and we've got the average speed for this one was about 90 kilometers an hour. Remember, that's not the speed that you're going the whole time. That's just, you know, if you averaged all the speeds up. Okay, so what does that mean? Well, if you're hiking, for example, you take these 3 sections in your hike, and that means that you're, you know, if you add all these times up and you add all the distances up, you can figure out how fast they're going. And remember, it's like an average of their speeds. If you want, you can think about it. In this first bit, they're going 9 kilometers an hour, and this last bit's going a bit slower. It's going 8 kilometers an hour. If you average, and then for 10 minutes, it's going 0 kilometers an hour. If you average those together, that's how you get the average speed. Instantaneous speed is the opposite. That's the speed of right now at a split second. So it's literally, if you were to look at one of these legs of his journey, you would say what the instantaneous speed. Instantaneous speed here was 0 kilometers an hour. That's instantaneous. It's exactly that point in time. You can find that using a gradient, or remember, you can use the formula V equals dt, but you have to remember that it's for a specific section of time. And then I gave you guys the work to do. Now, what I'm going to talk to you guys about ticket timers. Now, I really have a love, no, I don't. I have a hate relationship. I hate ticket timers. I think they're stupid, and I don't like teaching them because I'm very much of the opinion we shouldn't be teaching you guys ticket timers because they're so old-fashioned. Personally, in my opinion, it's like taking you guys out and being like, right, guys, I'm going to teach you how to multiply using an abacus or a slide rule. It's like, no, you guys have got calculators for a reason. Let's use the modern equipment. All right, rant over. Sorry, I apologize for that. Let me
wait. What's ticket timers? What's that?
It's a device. We're about to learn what they are. That's the goal of today's lesson. I want you to be able to describe how they work. Now, I'm going to describe how they work, but I'm going to start off by using an analogy. So just bear with me and it'll make sense. What we're going to do is we're going to tell a story. We're going to tell a story of a boy with a bag of rice, okay? And imagine this boy has got this bag of rice and he buys it from the store, whatever, for $5 or whatever it is. And he leaves the store with a bag of rice to take the rice home. And then halfway on his journey with this bag of rice, he then discovers there is a hole in the bag. So he stops and he has a look at the hole in the bag and he goes, oh my God, I've been dropping rice this whole time. He realizes he can't fix it, so he runs home so as not lose too much. Jesus. So as not to lose too much rice. Man, if there are EAL students in the class, I want to say I'm deeply sorry for completely butchering the English language to them.
I think you butchered up spelling too. I think you sold the grammar book, by the way.
Yeah. No, that's the wrong.
Loose is spelled with
the wrong version of
It's all good, sir. It's all good.
Lose.
It's all good.
Anyway, so yeah. So what he's doing is he's got the rice and he's got the rice in a bag and he's dropping bits of rice as he's going. Okay? So what does that look like? Okay? These orange things on the ground, they're meant to represent the rice. Yeah?
The Pac-Man thingies.
Yeah. So what's going to happen is as he was walking along this part, he's dropping a grain of rice every so often. Okay, can you guys tell me, take a guess, where do you think he stopped to look at the bag?
At the cactus.
Cactus.
How can you know that's where he stopped?
Because you're not gonna walk into a cactus, are you? You're gonna walk and then you're
Because
gonna
the
stop.
ticker timers.
No, because there's heaps of it. There's heaps there.
There's heaps of rice. So he probably stopped here to look at the rice. And as
And
that's
it was probably
happening,
falling.
a bunch of rice is coming out.
Come
Now,
on, that's BS.
at this
See?
part here, right? Let's go have a look here. How come there is less rice here than there is here?
Because he lost them, obviously. He lost
he
them
ran,
all.
sir.
Rice. What was that, Brendan?
Probably the cactus.
Because he ran.
Because he ran. But why would that mean there's less rice if he ran?
Because they
Because
all
there's
fell
more-
out.
Because there's
No.
more time in between every. Wait, because there's less. Wait, less or more time in between every piece of rice that dropped.
Close.
Or he traveled further per rice that dropped.
That's the answer you want. So in this start part, right, on the left, right, he's traveling like, let's just say the rice drops out of his bag, one grain every second. Well, let's know, maybe one grain every 10 seconds. Okay, so that means that's 10 seconds, that's 10 seconds, that's 10 seconds. You can see he's moving at a pretty slow space. But here, all of these 10 seconds happen at the same point. So therefore, they're all dropping at that same point. That was the correct answer, Alethea. You're right. They're all dropping at that same point. But in this last section on the right here, that's still dropping every 10 seconds. But because he's running, he travels a further distance in that 10 seconds than he did at the start. This idea here is what we need to understand to be able to use ticker timers. I want you to understand this, and I really want you guys to look at this. When he's moving quickly, he moves a greater distance before he drops a grain of rice. He runs a large distance compared to here, where he moves a small distance. So when you see a bunch of dots close together, that's moving slowly. When you see a bunch of dots further apart, that's when he's moving quickly. So, or a bunch of rice further apart, that's when he's moving quickly. So what does this have to do with, and you guys, you know what, you might actually know this sound. You actually might be able to tell when this has happened if you've ever ridden a scooter or you know what, a skateboard over concrete pavers. Imagine you're doing a skate and you hear the da-dum, da-dum, da-dum. Every time your skateboard goes over one of those gaps in the pavement, or this, you know, when you know how the pavement's got little gaps between them, it makes a da-dum sound. If you're on a skateboard, and I'm saying skateboard, not bike, because it'd be hard to tell with a bike. But if you're on a skateboard, you're going really, really quickly, you will hear the ba-dum, 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 ba-dum really quickly, because happening, it's a shorter time between each bump. And that's how you know that you're going faster. But if you're going slow, it would be ba-dum, ba-dum, ba-dum. It's the same idea. So what's the ticker timer? Exactly that question. What is this ticker timer device? Can I get you to write this down? Sorry, I haven't put a pencil here. I apologize for that. Oh my God, that looks more like a knife. Okay, so what that means, instead of rice, we use an ink stamp in a ticker timer. And an ink stamp that puts a dot on a piece of paper every 0.02 seconds. So instead of every 10 seconds for a grain of rice, we're doing it every 0.02 seconds. Instead of rice, we're using a stamp. So it's the same idea, stamp, stamp, stamp. Now, instead of the road though, we're gonna use a piece of paper, and sometimes that piece of paper is known as ticker tape. Now, if you pull that ticker, we attach that ticker tape to a moving object. And so that means that as you pull the ticker tape, as the object moves and pulls the ticker tape out, it will put stamps on the tape. Okay, that's how it works. So if the dots are close together, that means the paper hasn't moved very much in that time. That means the object is slow. Just like if the rice is all bunched up together, that means the person is moving very slowly, because every second they're dropping a piece of rice. Every second we're putting on a dot on this piece of paper. So if the dots are really close together, you know you're moving slowly. But if the dots are far apart, then there is more movement for a set time, which means if there's more movement than for a set time, that means you're moving faster. I'm going to give you guys a second to jot that down. Yes, I'd like you to write this down, please. And then what we'll do is we'll talk about how we can then work out how fast something is going. Oh, I did do the pencil. Now, if you're a bit confused by how this works, I would 100% get that. It's really difficult to teach you guys what ticket tape is and ticket timers without you guys actually getting to play with them. It's actually a lot easier if I could give you guys each a ticket timer and you could see, because you could be like, oh, cool. All right, let's turn it on. Let's pull the paper really quickly. Wow, look at that. Let's pull the paper really slowly. Now, it's also the analogy that we used with the boy and the rice isn't actually is close to this analogy, but it's not the same. In the idea with the ticket time, but the idea with the boy with the rice is the boy is moving and dropping rice every so often. In this case, it would be the boy is staying still, but the road is moving, and then the whole analogy falls apart. But it's still the same idea. If every second, every 0.02 seconds you put a stamp, that paper is flying through really quickly, you could have 10 centimeters between each dot. But if it's moving through very slowly, you may only have half a centimeter through each dot. Can I change the slide, or do you guys need a little bit longer to write this down?
Should be all good, sir.
All good?
Yes.
Anyone else?
All good.
I'm going to change it.
Yeah, go.
Here we go. So this is, where's the pencil? There it is. How to calculate ticket times. So this is how we could actually calculate it. Now, first thing I'm going to do is the distance between each dot is 0.02 seconds. So for every 5 dots, 5 times 0.02 equals 0.1 seconds. Now, I'd like you to draw, you know what? No, yeah, well, I just want you to draw this. That's all I want you to draw. Okay. So if I could look at this ticket timer tape, let's see if we can see what's happening. Firstly, just by looking at it, I can see that this part here, the dots are far apart. So it's, and then this part here, though, they're quite close together. So if I was to write, I write fast, and then I write slow, and then I'd say this one here is getting faster. That's how I would interpret this tape, right? You can even interpret it by looking at the dots, yeah? The length of the strip. Here, in 0.1 seconds, we haven't moved very far, okay? Let's say, how would you measure this? And in this one, you've moved a bit slower, and this one, you moved a bit faster. How would you measure the speed? Well, speed equals distance over time. Okay, let's just say we measure this with a ruler, and we find that, let's say this is 4.5 centimeters. Let's say that 4.5 centimeters worth of tape came through. And this one's a bit shorter, so let's call this one 3.5 centimeters. This one's a bit longer, let's call that 5 centimeters. Now, if we actually had a piece of tape in front of you, I would actually get you to get a ruler out and actually measure this. But because we're trying to do this virtually, which is very, very difficult to teach this topic, I want you to understand that we kind of have to imagine it, okay? This is so difficult to teach, oh my God, okay. So, and I hate ticket timers as well so much, they make me so mad. Anyway, so if this is moved 4.5 centimeters, you could say it's moved 4.5 centimeters in 0.1 seconds. That means that we're traveling at 45 centimeters per second. That's how, and this one you would be going 35 centimeters per second, and this one we're going 5 centimeters per second. So that's how we can get the velocity of something, or the speed of something from the tape. You again could look at the ground you could imagine these as pieces of rice. Okay, if we know that a piece of rice is being dropped every 10 seconds, then we could say this is 50 seconds and they've gone 4.45 meters or something, and you could do the same thing. Now, what I would like you to copy down from this slide is I would like you to get some kind of picture that looks like this section in the orange. You don't have to copy the whole thing down, just as long as it's got those details, the 45 centimeters, and then I want you to get this section here written down too. And then that's going to be it for that slide. And then I've got one last thing I want to talk to you guys about, and then we're done. We're done for the day. So we're just going to give you guys a little bit of time. I'm going to give you from now about, because I've got 10 minutes left.
Does that say S dots or is it 5?
That's a bad 5.
Yo, I'm
Wait,
so
so-
confused about this
I
whole
know.
entire thing. This whole entire ticket timer bullshit. What is this? What am I learning? Am I learning about some kid dropping some rice or some shit? What am I learning?
So it's an actual device, right? Okay, here's the thing, right? If you know, you've just got to try it. I would suggest you actually watch a video of someone using a ticket timer. I might do that in the last 5 minutes. But yeah, the idea is every 0.02 seconds, it's putting a dot on the page. Okay. Imagine that, you know what, imagine that instead of this, like, if you want, Brendan, tell me if this helps you out. Imagine that you've got a person with a stamp, and they stamp every second, right? 1, 2, 3, 4. And then you've got like a roll of toilet paper, right? They're stamping this roll of toilet paper, yeah? You are slowly pulling that roll of toilet paper through. So the stamps are showing up. If you pull that toilet paper through really, really quickly, right? You pull that really, really quickly, those stamps are still happening every second. But a lot of paper is moving between each stamp. So those dots will be far apart. And that means you know that it's moving quickly. I'm going to jump into the actual next little bit here. Now, I don't like ticket timers, but...
So why teach it?
Hmm?
Just don't teach it. If you don't like it, well, then you don't like it. Just don't teach it.
Yeah, but the problem is, the problem that I have is that I might, like, I asked the other teachers, do I have to teach this? And they said, oh, they haven't said anything. And I don't want to skip it and then it show up on the test and you guys say, so you never explained this. I want to, and so I had thought I better teach it. And then, you know, it's better to teach it. You guys sort of understand it than not teach it. And you guys get it on the test and be like, oh my God, sir. So, but I will say there are some places where I do like ticket timers, which is there are other more advanced ways you can do this. Instead of using a pen and a dot and a piece of paper, are there other better ways to measure this? And there are. There's a device called a rotary encoder. Now I'm going to be careful here because I don't necessarily want you guys to do I guess I want you to get the main idea, and I'm going to write something down in the middle that I want you to write down, but I just want you to get this. So a rotary encoder, imagine you've got a wheel, okay? And this wheel is spinning around, right? Really quickly, right? Now, if that, let's just say we've got, and the light, right? Let's call this an orange light. That orange light is shining, and it's shining particularly through this hole. And then on the other side of the light, you've got a detector. What you could do with that is you could measure, right? If let's just say this is time. If you see the light and then there's a gap, and then you see the light and then there's a gap, and then you see the light and then there's a gap, and then you see the light and there's a gap. The reason it's dark is because it can only shine light when this hole is here. When the hole is covered up and the light, let's just say the hole is over here, no light's going to get through that hole. So what happens is that you can use this as the same idea as the ticket timer. If you see the light happen all the time, then you know that in this example, the wheel is turning really fast. And in this example, the wheel is turning really slow. And that's what they used to, that's a way that you can measure the speed of a car. Okay, now the speed of a car, so a rotary encoder, and this is what I'm going to get you guys to write down. So rotary encoders use light or magnets to measure the time of each spin. This rotary encoders use light or magnets to measure the time of each spin. This, full stop, this can be used to find the speed. Now, I'm going to be honest with you guys, these are they're not always super accurate,
Wait, I'm so confused about this whole entire thing, bro. Like, mate, I'm so confused.
Again, if I had a picture, it'd be a lot easier for me to explain it. Okay, I might, and if I had a little bit, I've had more time, I could have made like some kind of animation to show you. But think about this.
So boring. Fucking hell.
So the idea is, if you want another example to think about it, simply move your fingers apart and move your hand forwards and backwards. You can see through your hand every so often. You move it really quickly, you can pretty much always see through your hand. And that's how rotary encoders work, and this is also then how speedometers work, okay? So a speedometer will use magnets, and it does the same thing, except instead of looking for light changes, it looks for magnetic changes, and it can use that to work out the speed of your car. You're going really, really far and fast, and it will measure the speed of your car. And that's pretty much how they work. Well, that's pretty much it for the lesson, ladies and gents. It's now 3 o'clock.
Yes.
What I'm going to get you to do is, so this is going to be an actual ticket timer. So I'm going to not put the volume on. I don't think we need it. But let me just, so if he twitches it on, listen to this annoying sound. How annoying is that sound? And each one of those beats is the pad going up and down. So here's the paper, right? Paper goes in. And what we can do is, as that paper goes in, all we would do is just set it up so it works nicely. Come on, get to the action, get to the money shot. Here we go. So what he's going to do, he's going to tie the paper to like some kind of rock or something. No, to a car. Oh, cool. Okay, fine. Sure, whatever, doesn't matter. Then he's going to push the car. Yeah, you're fine, buddy. Come on, get on with it. Oh my God, what are you doing? Get with the action. Here we go. Now, that's it. Right? You might be like, okay, so what? So if you then look at the tape, right? See at the start, the cart was moving really slowly. So all these dots are close together. But as the cart pulled the paper, right, the cart's pulling the paper, the dots get further and further apart because the cart is getting faster and faster. So it's pulling, the idea is it pulls more paper through in a short amount of time. So he's doing that thing where he measures every 5th dot. You can see, look, the spacing between them is much larger because it's moving faster. And that's pretty much that. I love it. Yeah, it wasn't a great video, but yeah, that's all it does. Is it? But what I want you guys to see is this. See how it's pulling the paper through the ticker timer. And that's how it works. But yeah, Brendan, that's, I don't know how to, I can keep trying to explain it, but like that's the sort of idea is every every second it's pushing down and making a dot. So if your paper is going really quickly, then there's going to be big gaps, because if it's going every second, there is a big gap between them, right? I don't know. They're like, again, and it's the same idea of the rice. If you're dropping a grain of rice every second, if you're legging it, then there's going to be big gaps between where you drop those rice. But if you're walking slowly, there's only going to be small gaps between where each grain of rice is. If you know how much space there are between each gap, and you know that it's coming out every second, you can calculate the speed. Are there any questions or queries?
So you're telling me the slower you go, the closer the dots are going to be. And the faster you go, the more space there's going to be.
Yes.
Okay, cool. That just sums up the whole entire lesson. Let's go.
That's it. That's all. Honestly, if that's all students walk away with, if that's all you got from today's lesson, hey, when the dots are closer, it's moving slowly, then perfect, done. Great,
Let's go.
cool. That's
Let's
it.
go. Well,
Um,
that was like what, 1 minute, and I just understood the whole entire lesson.
yeah, I know, but that sometimes happens. Sometimes it just takes a while for people to get the whole, oh, that's how it works. Obviously, with a rotary encoder, it's a little bit different, but you don't need to know that. You don't need to memorize how a rotary encoder works. Like, I was just showing you that so that you could see the same idea is actually used in cars. Like, they actually use this idea. The only difference is that you're just measuring, well, how quickly is it between each like source of light? Okay, cool. It's the same idea. It's just flipped a little bit around. But yeah, that's the main idea. Cool. You've got it. You know what the homework is. It's now 3:06. I'm going to dismiss you.